All right, so this is your Unit 2 factoring and quadratic graph review. We start out with this very first problem, or first two, that say factor the common factor out of each. Well, that's what greatest common factor stands for, and that's really what it means, is the greatest one. So I take this piece by piece. First, I look at the numbers. 45, 90, and 81. And I'm trying to think what's the largest number that can go into all three of these. Okay? Off the top of my head, I think about 3, but also I know my times table is okay, and I know that 9 can go into 45, 9 can go into 90, and 9 can go into 81. So I'm going to try that. I pull a 9 out. What that does to everything inside is it divides it by 9. So 5a to the 7th b cubed minus 10 a cubed b minus 9a cubed. So all I've done so far is divide out the 9. And that's great because now I look inside, I notice 5, a 10, and a 9. There's no number that goes into all of those, so I got the biggest number out. But my work's not done. The number's only part of it. Next, you have to consider the variables. I start with the a's because they just are written first. I see that I have an a in my first term, an a in my second term, and an a in my third term, which means I can pull out some of the a's. I figure out how many I can pull out by looking at the exponents. The lowest exponent is how many I can take out. 7, 3, 3. So 3 is my lowest exponent, which means I can pull out a cubed. I can divide it out. My number doesn't change, it's 5. If I have 7 a's and I take 3 of them out, I'm left with 4 of them. If I had 3 a's and I took 3 of them out, I'm left with none of them. And if I had 3 a's and I took 3 of them out, I'm left with none of them again. Notice all the b's stay the same. And those b's are what our last step is. I look at my first term, I see that it's got a b. My middle term has a b, but my third term doesn't have a b. Therefore, we cannot take any of the b's out. We cannot take any of them out. So our final answer is right there. Greatest common factor. Number 2 is a little bit easier. It's a more simple version of a problem. It says we want just the greatest common factor. This is kind of, first 2 problems are just us easing you into the test a little bit, saying, hey, look, let's start off with this greatest common factor step. Let's make sure you can do that, okay? When I look at these numbers, I see that we have a 5 that can go into both, but the bigger choice is a 10 that can go into both. Because this is a leading negative, most places will go ahead and pull out a negative 10. That would change this to be a 5a. Minus 10 divided by negative 10 is going to just be a plus 1. Guys, if you're ever not sure that what you pulled out was correct, remember, if you want to check it, it should distribute back in and get the original. Negative 10 times 5a is negative 50a. Negative 10 times 1 is negative 10. That's our original problem, so it checks out. With number 3, we arrive at our next section, which is factor each completely. Completely. Okay? So, to factor this completely, I first look for a greatest common factor. That makes the problem easier, so always start with that. There's no number that can come out of all 3 of these, and there's no in every single term, so we can't pull out any variables or any numbers, so we just hop right into our box method. To do that, our step is we multiply our first term and our last term, giving us 24n squared. Then we have our little tree. We want them to multiply to be 24n squared, but add to be this middle term. So I'm thinking of numbers that multiply to be 24. I'm building that little factor tree or that little T-chart. 1 and 24, 2 and 12. That's the first one that strikes me as one that might work. 3 and 8, 4 and 6. Then we would get back to 6 and 4, which is a repeat. Okay? 1 and 24. If I add them, I get 25. If I subtract them, I get 23. That's not 10. I'm looking for 10. 2 and 12. When I add them, I get 14. But when I subtract them, I do get 10. So the first thing I'm thinking about is 2n and 12n. If I add them, I get positive 14. So I need this one to be negative. So now when I add them, I need this one to be negative. So now when I add them, I get negative 10. But when I multiply them, I get the wrong thing. What that tells me is those two actually didn't work. So I got to keep hunting down my tree and hope another set works. If not, it's not factorable. 3 and 8, 11 or 5, if I add or subtract, not going to work. But 4 and 6 could work. If I make them both negative, I get negative 10n, and they multiply to now be a positive 24n squared. So that pair looks like it's going to work out. I start my box. And I've seen a lot of people today having trouble remembering where to get the pieces, okay? Our n squared and our 24 go directly in the box. N squared, 24. Our negative 4n and our negative 6n are the other pieces. Essentially, we have an n squared that goes in the box, 24 that goes into the box. And look, this negative 10n, we split it up. Look, we split it up right here into a negative 6 and negative 4. So that's where those other two pieces come from. It's essentially just our original polynomial, except for we split up that middle term. And now we're ready to GCF this. Across my top row, I get n is my greatest common factor, okay? Because I can't pull any numbers out. Across my bottom row, I see I can pull out a 4 out of both of these numbers. And because this is negative, it makes the number next to it negative. Across my top, or across my first column, I see that I can pull an n out, and then I can pull out a minus 6, giving us the answer n minus 4, n minus 6. I had one person ask me earlier today in, first block, I think. Yep, first block. And they said, Mr. Sorrell, once we get to this step, can't we just shortcut straight to the answers? The answer is yes, you can, because this is a leading or a leading coefficient of 1. If it wasn't a leading coefficient of 1, you would have to work the problem out. Okay? So we could have shortcut from minus 4 and minus 6 to minus 4 and minus 6 and just shortcut the problem right there. Okay? On to number 4. This one only has 2 pieces. Okay, so I'm already thinking maybe it's a difference of perfect squares, but before I do any of that, I want to go ahead and greatest common factor this. I just off the top of my head can see that 4 goes into both of these, because 4 times 9 gives me 36, and I know 4 is going to go into 125 times. So if I take a 4 out of both, I get 9x squared minus 25. Now again, you don't have to do that, but it makes the problem a lot easier. Because now we're saying, oh, look at this. Perfect square. Perfect square. That means we can shortcut this and go straight to our answer. Our answer means we're going to open up some parentheses. 9x squared means it's 3x and 3x. 25 becomes 5 and 5. So we have 3x plus 5, 3x minus 5 with our 4 out front. Remember though, if you don't like that, you can still do the box method. Let's pretend we're back here at this original step, okay? If we multiply these two terms together, we get negative 225x squared, and we want them to add up to be the middle term. Well, the middle term's not there. There's no middle term, or it's 0. You would look on your calculator by doing your multiplications and realize that negative 15x and 15x would work. I'm doing this faster. Obviously, you would have to discover all of this, but I'm just trying to get us through because the shortcut's a little bit easier, but this method will work. We have 9x squared in the box, negative 25 in the box, negative 15x in the box, and 15x in the box. Our greatest common factor is 3x and negative 5, 3x and positive 5. And so you see 3x plus 5